Imagine you run a massive online food delivery business based right here in Accra. Your customers are ordering from Kumasi, Tamale, Lagos, and even all the way out in London. To keep that app running smoothly without crashing, you need serious computing power. But how do you choose the right setup? Well, welcome to this explainer brought to you by Cloud with Shed. Today, we're going to use a calm, clear, and beginner-friendly approach to demystify AWS compute services. Whether you're just breaking into tech or gearing up for your next certification, we're going to walk through this together, step by step, making it a story you'll never forget. So, let's establish right up front why this matters so much. If you're preparing for a certification, compute is basically your foundation. I mean, look at this. It makes up a massive 34% of the AWS Solutions Architect exam and a really solid 25% of the Cloud Practitioner exam. You literally cannot pass without understanding these services. But beyond the exams, compute is the actual engine of the cloud. It's where your applications live, breathe, and serve your customers. To get you completely exam ready, we're going to journey across what we call the compute spectrum. We'll start by demystifying EC2, then we'll look at serverless, Lambda, dive into containers and Beanstalk, cover cost and auto-scaling, and finally wrap up with exam success tips.
Okay, Section 1. Let's start by demystifying EC2, which is your core virtual computing resource.
When you launch an EC2 instance, you're essentially renting a virtual server, and you have to choose its hardware profile. Think of it like choosing the right delivery vehicles for your Accra fleet. To easily memorize the instance families for the exam, just remember the acronym GCMSA. G is for general purpose. That's your standard balanced delivery car. C is compute optimized, perfect for heavy processing. M is memory optimized, built for massive databases. S is storage optimized, for huge amounts of local data. And A is accelerated computing, which uses high-end hardware like GPUs for machine learning. Knowing GCMSA will quickly help you match the right server to the right job. Now, here's a really interesting distinction you need to know regarding storage. There is a hard boundary between Amazon EBS and Instant Store. EBS, or Elastic Block Store, is persistent. Think of it like a heavy, permanent steel safe in your office. It completely survives even if you terminate your server. Instant Store, on the other hand, is incredibly fast because it's physically attached to the host, but it is ephemeral. That means it's temporary, like a display table in a shop. The moment that server stops or terminates, that data is wiped out, gone forever. Your billing choices dictate your entire cloud strategy. It's kind of like renting a shop. You have flexible on-demand pricing, where you pay by the second with zero long-term commitment. Then you have reserved instances and savings plans, which give you up to 72% off for committing to a 1 or 3-year term. But the real game changer? That's Spot instances. Spot offers up to a staggering 90% discount. But there's a catch. AWS can reclaim that instance with just a 2-minute warning. So you only use Spot when your application can survive a sudden interruption.
Before we leave EC2, we have to talk about security. Exam creators love hard rules, and this is absolutely crucial. Never, ever hard-code passwords or access keys onto your EC2 instances. Just don't do it. Instead, you always want to use IAM roles. By attaching an IAM role, you grant secure permissions directly to the instance, and AWS handles rotating the temporary credentials for you behind the scenes. It's cleaner, it's safer, and I promise you, you will be tested on it.
Moving right along to Section 2, let's look at peak abstraction with serverless Lambda. Okay, look at this number. This is a critical exam fact. 15. Lambda has a strict maximum execution time of 15 minutes, or 900 seconds. If you have a task that takes 16 minutes to process, Lambda will simply time out and fail. Burn this 15-minute rule into your memory, because it's a massive shortcut for eliminating wrong answers on test day. Now, you wouldn't use Lambda to host an always-on web server. Instead, it's totally event-driven. Imagine a customer in Kumasi uploading a profile picture to your food delivery app. The exact moment that image lands in an S3 bucket, Lambda is triggered to automatically resize it. Or maybe it triggers when a database record in DynamoDB updates. Lambda just sits quietly, costing you absolutely nothing until an event wakes it up to do its job. Then you only pay for the exact milliseconds it runs. Awesome. Let's jump into Section 3, Containers and Elastic Beanstalk. This is the middle ground of packaged control. When dealing with containers on the Elastic Container Service, or ECS, you have a major choice to make. You can use the EC2 launch type, which means you are personally managing the underlying servers yourself, total control but more work. Or you can use ECS Fargate.
Fargate is serverless compute for your containers. You literally just hand over your container, and AWS manages the entire infrastructure. It takes the server management completely off your plate.
But what if you don't even want to mess with containers? Say you just have your application code, maybe written in Java or Python, and you just want it live on the internet. That's where Elastic Beanstalk comes in. It's a platform as a service. You simply upload your code, and Beanstalk automatically handles the servers, the load balancing, and the auto-scaling. It's basically a fully automated, ready-to-go deployment engine. I highly recommend taking a mental screenshot of this matrix. It perfectly breaks down when to use which service based on the management you want. EC2 gives you raw infrastructure as a service with total control. Lambda is pure serverless for short tasks. Fargate handles your serverless containers, and Beanstalk is your platform as a service for automated app deployment. Keeping this map in your head will save you so much time.
All right, Section 4. Let's talk about cost and auto-scaling to keep things highly available.
Imagine thousands of hungry customers across West Africa trying to use your app all at the exact same time. To stop your servers from crashing, you need traffic wardens. That's what load balancers do. You need to know these three. The application load balancer is for standard web traffic, operating at layer 7 to route HTTP requests. The network load balancer operates at layer 4. Use this when you need ultra-fast, extreme performance with millions of requests per second. And the gateway load balancer operates at layer 3, specifically to help you scale third-party network security appliances like firewalls. We've made it to our final section, Section 5, Exam Success. Let's do a rapid-fire review. Notice the problem and solution rhythm you're going to see on the exam. If a scenario describes a predictable 24/7 steady workload spanning 3 years, you lock in reserved instances. Need that same discount but might want to switch server families later? You pivot to savings plans. If the question mentions a fault-tolerant batch job that can handle being interrupted, spot instances every time. And if they mention machine learning or high-end graphics processing, jump straight to accelerated computing EC2 instances. Let's look at how this builds into your ultimate study checklist. Make sure you've mastered the GCSMA instance families. Remember the stark difference between serverless Fargate and managing your own EC2 instances. Never hardcode those credentials. Use IAM roles. And, of course, that strict 15-minute limit for Lambda. I'll leave you with this provocative thought to wrap up. If your application code takes, say, 45 minutes to process a massive video file for an online course, which heavily promoted compute service do you have to completely leave behind? Think back to that hard boundary we discussed earlier. Yep, you got it. You have to leave Lambda in the dust and look toward EC2 or ECS. Keep returning to these slides, keep matching these scenarios to the concepts, and you are absolutely going to crush your AWS exam. Thanks for learning with Cloud with Shad.